In this video, we're going to discuss the functions of lenses. So lenses have at least one curved surface and they refract light in a particular way. So unlike a mirror that reflects light, lenses refract the light. And the extent that the rays converge or diverge is determined by the material the lens is made of and its shape. So both of those things matter. A converging lens makes parallel light rays come together, like the one in the top. So a converging lens curves outwards on both sides. And then a diverging lens will make parallel light rays move apart from one another. So you can see this one, it's concave on both sides. So then the light rays diverge once they pass through the lens. So because lenses have two sides, there's a focal point on both sides of the lens. So when parallel rays are close to the principal axis, as you can see here, are passing through a converging lens, the rays will all meet together at one point on the other side of the lens. And that point is known as the focal point. And the rays are drawn so that they refract only once, and they do that at the center of the lens. So if we were drawing a ray diagram, we would draw a parallel line, find the center of the lens, and then it would refract and go through the focal point. So you can see that they're all converging here, and then they diverge again after the focal point. So let's go through the steps for drawing ray diagrams with lenses. We're going to do the converging ones first. So we're going to draw a ray from the top of the object parallel to the principal axis. At the middle of the lens, we'll draw that it refracts and goes through the focal point on the other side of the lens. Then you draw a second ray from the top of the object. You'll draw it through the focal point on the same side, and then you'll refract it parallel to the principal axis. And that ray will cross your first ray, and then you can draw the image so that the top is where the two rays cross. So let's go through this. I've already drawn the drawing as well. It's a little harder to do. So here's my pencil. This is my object. I'm going to draw a parallel line from the top of my object and then refract it through the focal point. And then I'm also going to do another line through the first focal point to the center of the lens and then parallel across. Where the two lines meet is where my object is. The top of the object is where the two lines originated, and the top of the image is going to be where the two rays met each other here. And let's talk about the loss characteristics. So the location, it's the same distance from the lens. It's inverted, its orientation is inverted. It's the same size, and it's a real image. We didn't have to extend light rays to find our image. So I've started this one already. So our object is here. So again, this time the object's before the focal point. So I drew a parallel line in and then it refracts through the focal point. The second one, I started from the focal point over the image and then it reflects parallel back. These lines are never going to cross. They're diverging on this side. So what we need to do is we need to extend our reflected rays or refracted rays by a dotted line. So this one goes like so, and then this one's going to go like so. So now where they cross, our image is going to be here. There's our little pencil, like so. So our loss characteristics this time, it's further away than the image object. It's upright. It's larger. And this time it's a virtual image. So these are much better drawings than mine. So if the object is beyond two focal lengths from the converging lens, the image characteristics are going to be that it will be closer to the lens than the object. It's going to be inverted. It's going to be smaller and it's going to be real. If it's between the focal point and the converging lens, then they're farther away than the object. They're upright, larger, and virtual. And if they're between 1 and 2 focal lengths from the object, or the lens, sorry, they will be farther, inverted, larger, and real. So in our original drawing, it looked like it was the same distance, but it would have been a little bit further and a little bit bigger, but it still was a real image. We're not going to do practices with image characteristics for diverging lenses, but what happens to them is that they will be closer to the lens, the image. It will be upright, smaller, and virtual. So there's where the image appears. So we drew it and we reflected it through the first focal point and then down through the center and across, and then through the center across the top of the image and straight down. So that's how that formed the image.